So I'm moving back and reached here D. So here D is derived as TL. That means TL is reduced to D. So what happens? We have to perform this action. Whatever be the type of T, that has to be assigned to the type of L. Whatever type T has, that has to be assigned to this L. So in this reduction, the T has got the type real and that has to be assigned to this L. So L dot type gets a value real. So that will be updated in this symbol table entry. So once this L value gets its type as real, that has to be updated in this L also. So when this L is updated with the value real, that has to be entered in the symbol table entry corresponding to A. So considering these two SDDs, that is the first one shown and the current SDD, we can infer a few things. Here the attribute we are considering is a type attribute, and here the attribute we are considering is the value attribute. So here we can see for each of these attribute gets its value from its child node. This E gets its value from its child E value and T value. This attribute gets its value from its child E dot value, F dot value. Similarly, this F dot value gets its value 3 from its child num dot lexical value. So this means that this attribute gets its value from the child. So such attributes are called synthesized attributes. If an attribute value is derived from its child node, then that attribute is called a synthesized attribute. So value is a synthesized attribute because it gets its value from its child. Now coming to this example, here you can see that this type gets its value from here. Okay, but this type attribute gets its value from its sibling T dot type, not from its child. And similarly, this L gets its attribute type from its parent. So once this L dot type gets a value real, that will be given to this L. So here the attribute gets its value from its parent. Here the attribute gets its value from the siblings. So those attributes who gets a value from its parent or siblings are called inherited attributes. So if an attribute gets its value from its parent node or from its siblings, then they are called inherited attribute. So these are several terms we have to keep in mind while studying the syntax directed translation. The first term you have to keep in mind is what is a syntax directed definition. A syntax directed definition is a grammar and a semantic rule. And for syntax directed definition, there are two notation, SDD and translation scheme. So we have studied only what an SDD is. Translation scheme will be studied later. So syntax directed definitions are we studied, and we studied how what a SDD is. SDD will contain a set of production. Attached with each of this production there will be a semantic rule, and this semantic actions will be performed whenever we reduce from the right hand side to the left hand side. Whenever there is a reduction occurs from the right hand side to the left hand side, these semantic rules or semantic actions will be performed. And attached with every symbol there will be a set of attributes, and these attributes can be either synthesized attribute or an inherited attribute. Synthesized attribute or an inherited attribute. So what is a synthesized attribute? If an attribute gets its value from its child node, then that attribute is a synthesized attribute. If an attribute gets its value from its parent or from its siblings, then such attributes are called inherited attributes. Few other terms you have to keep in mind is about an annotated parse tree. What is a annotated parse tree? So this is an example for an annotated part, that is decorating the parse tree. Initially we obtain a parse tree and later we are decorating the parse tree with using the semantic rules. So that is known as an annotated parse tree, and the process is called annotating or decorating the parse tree. So what an annotated parse tree is? A parse tree showing the value of attributes at each node is called an annotated parse tree. The process of computing the attribute value at the nodes is called annotating or decorating the parse tree. So initially we will draw the parse tree. After that we will decorate the parse tree with the attribute value. So finally we will get the annotated parse tree. So this is the annotated parse tree for this grammar for the given input. And this is the annotated parse tree for this given input for the SDD given. Okay, so these are the few terms you have to be familiar with while studying the syntax directed definition. And you can do, and there is another thing, construction of syntax trees. You know what a syntax tree is? Construction of syntax tree. So this is an example for a syntax tree. That is, for example, if the given expression is 3 into 5 plus 4. So this will be the syntax tree. 3 into 5 plus syntax tree is a condensed representation of a parse tree. So in when you studied intermediate chord generation, we have studied syntax representation. A syntax tree can be drawn in two ways. One by using the node representation and another by using a record representation. So here we are studying the construction of a node representation. So suppose, so there are three functions for the construction of a syntax tree. Make node, this is used to create intermediate nodes. And make leaf which is used to construct the leaf nodes. So leaf node can be either an identifier or can be a number. For example, suppose if my expression is a minus 4 plus c. So a is an identifier, 4 is a number. So a minus 4 plus c, in which a, 4 and c will be the leaf nodes and plus and minus will be the intermediate nodes. So how we will perform? First we have to create a make leaf. Since a is a simple or a terminal symbol, that will be appeared as the leaf. So you have to make leaf for leaf. How to make the leaf? So make leaf id entry. So id will be there and the entry will be a. For the number, you have to use this function make leaf number and the value 4. Here also make leaf for c, it's an identifier and the entry c. So how to draw the syntax tree? Syntax tree will be look like this. id minus 4 and this node is created using this function make node. So operator is the first one, minus is the first operator, and there is a pointer to the left child and a pointer to the right child. So a minus 4 will be written in the node representation like this, a minus 4. So simply we can draw like this, a minus 4 plus c. So this is a simple syntax tree. The node representation would look like this. So leaf nodes, for an identifier, the leaf node function will be this, and for the number, the leaf node function will be like this. For the intermediate node, that is minus and plus, minus got two child, left child and right child, and an operator value. So make node, minus will be the operator, left pointed to the left child, pointed to the right child. Similarly for plus, that forms an intermediate representation. So you have to use make node with operator as plus and pointed to the left child and pointed to the right child. So plus is given, pointed to the left child and pointed to the right child. So this is the node representation for the given simple syntax tree. So let's look into the SDD for creating a syntax tree. So this is the SDD for constructing a syntax tree. Let's see how to construct the annotated parse tree for this SDD. So 3 minus 4 plus 5, and this is the grammar. So initially we have to derive this. So I am starting from here. E derives E plus T, and for E I am writing E minus T, and for E I am deriving T and T to num. Here the value of number is 3, here the value of number is 4, again T to num, it is 5. Okay, so this is the parse tree. Now I am going to annotate this, decorate this parse tree and construct the node representation for this syntax tree. So starting from the beginning, E to T is a derivation and E to T is another derivation. It comes here. Now we are going to the reduced tree. t derives number. So I am going backwards. So number is reduced to t. So what happens? So here please see here the attribute value is pointer in PTR, not pointer. Okay, so we have studied type as an attribute, value as an attribute. So this is another type of attribute, memory location or a pointer. So when you comes here, there is a reduction. Number is reduced to t. Number is reduced to t. So what happens? You have to create a make leaf. So I am creating a node make leaf with number and number value. The value of the number is 3. So this is the leaf node I have created, and I have assigned a value 100, memory location 1000 to this, and that should be given to n.npr. So n.nptr gets the value 1000. Okay. Again I am moving backward. So t is reduced to e. T is reduced to e. So what is the action? Whatever memory location t has, whatever pointer value t has, that has to be given to the pointer value of e. So e.nptr also becomes 1000. So again I am moving backward. So now come to another reduction, number to t. Number to t. So again I have to make a leaf node. So I am going to make a leaf node with the number. Here the number is 4. So number 4, and I have assigned a 1010 memory address. So this t.nptr gets the value 1010, and I am again moving backward, traversing the tree, and this is again a reduction, number to t. So I have to make another leaf node with the entry number and the value 5. Let the memory location be 1020. So t.nptr gets the value 1020. Now I came here. When I reach here, there is a reduction. E minus t is reduced to e. E minus t is reduced to t. So there is another action to be performed. We have to make a node. So I am going to make a node with minus, and the left pointer as e pointer and the right pointer as t pointer. So when I come here, the left pointer is like this 1000, and the right pointer is 1001. So I have to draw a left pointer to this 1000 and a right pointer to this 1010. Left pointer to 1000 and right pointer to 1010. And this is the new address. Let it be 2000, and this 2000 has to be stored in e.nptr. Gets the value 2000. Now I reached here. So e derives e plus t. So this is the derivation, which means that e plus t is reduced to capital E. So I have to make another node. I have to make another node with plus and with e pointer and t pointer. What is the e pointer? 2000 and the t pointer is 1020. So the left child will point to 2000 and the right